This is lesson 45, solving systems by substitution, day 2, or warm-up. Solve these by graphing. We'll do the first one in red. Our y-intercept is 1. Our slope is up 4 over 3, or down 4 and left 3. Do our next one in orange. Y-intercept is negative 2. Slope is up 1 over 3, or down 1 left 3. And we can see that our lines intersect at the point negative 3, negative 3. Solving this system by substitution, we can look at this top equation. 7x plus y equals negative 20. And we can see that we can subtract 7x from both sides and solve for y. Our first step is to solve one of the equations for one of its variables. And now we'll take this value for y and plug it in for y in our second equation. 6x minus y equals negative 6. And we're substituting in a negative 7x minus 20. And we distribute our negative 1, so 6x plus 7x plus 20 equals negative 6. 6x and 7x makes 13x plus 20 equals negative 6. Subtract 20. And 13x equals negative 26. Divide by 13, and x equals negative 2. Now we're going to take this value of x and substitute it into our top equation for x. Y equals negative 7 times x minus 20. And we're substituting in a negative 2. So y equals positive 14 minus 20. So y equals negative 6. So our point is negative 2, negative 6. So for today's lesson, we're just going to practice some. So you guys practice doing these two. Again, take a second, hit pause. We can see this equation, that this is the same as y equals 3x plus 1. So our y-intercept is 1, and our slope is up 3 over 1, down 3, left 1. And we've got a line. And our next equation, we need to do a little work to it. 3x equals negative 3 plus y. If we added 3 to both sides, we'd get y equals 3x plus 3, or y equals 3x plus 3 going this direction. And our y-intercept is 3, and our slope is up 3 over 1. Down 3 over 1, down 3 over 1, down, down 3 over 1, and we can see what's happening in these equations. Are these lines ever going to run into each other? And the answer is no. And what do we have? We've got lines with a slope, both of them having a slope of 3, and they both have different y-intercepts. So same slope means we've got parallel lines, and so when we have parallel lines, we've got no solution because our lines aren't going to intersect. This equation, our first step is to solve one of the equations for one of its variables. So we can solve this. Let's solve the top equation for y. So we've got negative 3x plus 3y equals 4. And if we add 3x to both sides, we get 3y equals 3x plus 4. And we divide by 3. And we get y equals x plus 4 thirds. And so now we're going to substitute this in for our value of y in the second equation. Rewrite the second equation as 9x minus 9 times y equals 7. And we're substituting in an x plus 4 thirds. We'll have to distribute our negative 9, so 9x equals negative 9x minus 3 goes into 9 3 times, so that's really negative 3 times 4, which is 12. We'll combine our like terms. 9x minus 9x cancels out, and we've got negative 12 equals 7. Does that make sense? No. So when we're doing substitution and we get something that doesn't make sense, then that's how we get no solutions using substitution. So either way, graphing an equation with the same slope and different y-intercepts will give us no solution. And when we use substitution and we knock out a variable and we don't get anything that works, then we say, hey, that doesn't work, so we must have the same slope. We can prove this, and I'll bet our slope is 1 by solving the second equation for y. So if we solve this second equation for y, we'd subtract 9x from both sides, and we get negative 9y equals negative 9x plus 7. Divide everything by negative 9, and we get y equals x minus 7/9, and we can see that our slope is 1, and our slope is 1, and we have different y-intercepts. So same slope, different y-intercepts, we have parallel lines. And our last example, try doing this one by substitution. So this, if we take our second equation, negative 6x plus 3y equals 18, and we solve that for y, we'd add 6x to both sides, and we get 3y equals 6x plus 18. Divide by 3, and we get y equals 2x plus 6. And now if we substitute in our value of y into the top equation, which is 6x minus 3y equals negative 18, and we substitute in a 2x plus 6, we'll get 6x minus 6x minus 18 equals negative 18. Combine our like terms. 6x minus 6x is 0, so we get negative 18 equals negative 18. When we get something like this that makes sense, then our answer is all real numbers are solutions. So this is all real numbers are solutions. Any point on that line is a solution. We can prove that by solving the top equation for y. 6x minus 3y equals negative 18, and what we're going to get is that same equation, because that's what it has. We'd be graphing the same equation twice. That's how all real numbers are solutions. So we subtract 6x, subtract 6x, and we get negative 3y equals negative 6x minus 18, divided by negative 3, and we get y equals 2x plus 6. So we'd be graphing the same equation twice. Alright, our homework tonight is lesson 45. So we just learned all real numbers are solutions, and that's when we're graphing the same line on top of itself twice. That's all real numbers, and we learned no solutions when we have parallel lines are no solutions. And this is all real numbers are solutions.